Welcome to Chain of Thought Prompting. This technique asks the model to write out its reasoning steps before the final answer, making results more accurate. Let's see how it works with a simple example. The shop sells pencils in packs of 4 for $3. Mia needs 10 pencils. How much does she pay? The model jumps straight to $7.50. Wrong. It priced 10 loose pencils, but the shop only sells whole packs. The middle step, how many packs, was never computed. Same question, different results. Without instructions, the model jumps straight to $7.50. Wrong. Add one line. Think step by step. Now it writes its reasoning, then answers $9. The fix isn't a smarter model, just asking for the steps first. Here's the flow. The question and instruction go into the model. Then it writes step 1, 2, and 3 in order before the final answer. The key: each written step becomes context for the next, so reasoning builds gradually and coherently. All these steps and answers happen in one model call. Nothing is trained, no weights change. The reasoning is just text the model writes, its own scratch space inside the call. Let's trace it step by step. First, Mia needs 10 pencils. 2 packs hold only 8. Still not enough, so she must buy 3 whole packs. Second, 3 packs times $3 each equals $9. Third, Mia pays $9. Now compare the earlier $7.50. The one jump answer skipped the whole pack step, exactly where the chain of reasoning caught the trap. So when does chain of thought actually help? For multi-step questions, like counting packs or comparing deals, writing out the steps clearly wins. For a simple lookup, such as one pack's price, extra steps just add tokens, time, and cost. And remember, a fluent chain can still be wrong. Spot check the reasoning when it matters. Ask for steps before the answer. Let each step feed the next within a single call, and skip it when reasoning isn't needed. Remember the flow: question, steps, then answer.